Okay, so we're going to deal with some powers. So what happens when we have each of the variables occurring kind of more than once? So how do we deal with those powers or indices? So let's have a look at the first of the power rules. If I have a times a, then that's going to make it bigger. All right, so a by a actually gets us a squared. Right, if I have a times a times a times a, that gives me a to the power of 4. Now, I'm actually making things bigger here. If you think about if you multiply a number, it tends to make it larger. That's what's happening here. Okay, and be very careful not to muck this up with adding. Adding just gives you more. Multiplying makes everything bigger. Okay, what if I've got a squared times a4? Well, you can kind of see my answer above, because if I've got a squared, it's a times a, and if I've got a4, it's a times a times a times a. So if you have a look at it, it's actually a6, right, or a to the power of 6, okay, right? Now, if you have a look, there's a bit of a shortcut here. You can count them all, and that's all good. But if you have a very careful look at what happened with the powers, can you see that you added them? So the 2 and the 4 here actually were added together, and that gave you the number 6 here. So you can do a little shortcut when you've got indices, as long as the bases are the same. If the bases are the same, don't touch them. Okay, and you can shortcut it. So rule number 1 for powers, when you multiply powers of the same letter or number, you add the indices. Pretty easy. So let's have a look at some questions here. If I've got a3 and a6 and a squared, I can multiply them all together, so it's going to be the base of a. And then if you have a look, there's 3, 6, and 2, that is going to be 11. Okay? So it's actually a times 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 a, or a11. Okay, C3, C5. Now, on this C here is actually the power of 1. Okay, didn't draw that one very well, did I? Hang on, just try and get it. A to the 1. So when you see a C by itself, you need to think, it's not actually just sitting there. It's actually got a power of 1. So if you have a look with this, that's 3, 5, and 1, which of course is C to the 9. Okay, let's try this a little bit harder now. 2 times 4, remember when we were multiplying? So 2 4s are going to be 8, and then y squared, y5 is going to be 8y7. Okay, and 3m cubed times 4m to the 5th. 3 4s are 12, and then the m is going to be the power of 8. Okay, let's see if we can do these harder index questions. Right, there's 2 at the front, and there's just a 1 in the front of the other one, so that first number is going to be, answer is going to be 2, and then a cubed and a6 is a9, and b6 and b2 is b8. Question 2, actually, let's get all 4 questions up here first. Okay, oh, there we go, I was correct for question 1. Question 2, 3 5s are 15. Okay, so that'll be the number at the front. Then we've got C5 and C2, which is C7, and we've got D8. Good job. 2 4s are 8. Now remember that A has got a power of 1 on it, so that's 1, and another 2 over there is A3. And then we've got B4, B3, which is B7. So I should have 8, A3, B7. Bonza. Last one, be careful with M's and M's and N's. Okay, it gets a little bit confusing. I've got 3 4s are 12, so that's going to be the coefficient at the front. M, I have M there and M there. That's M1, which is M2. I have N1 on this side and N2 on that side, so that's going to be N3 and P8. Brilliant.